Hello everyone. Today we will take a closer look at the types of problems that AI systems are expected to solve. And we will examine their characteristics, that is, the specific properties that define how easy or difficult they are to solve using an artificial agent. So, just like in human life, not all problems are the same. Some are clear and structured, others are vague and unpredictable. Some require simple decisions, others require planning and reasoning. And as we'll see today, the way a problem is structured directly influences the methods we use to solve it. So now uh, let's begin with the core question. What do we mean by types of problems? So in artificial intelligence, problems are broadly categorized based on their structure, information availability, predictability of outcomes, and the number of agents involved. So understanding these types helps us decide, should we use a simple rule-based approach? Do we need probabilistic reasoning? Do we require planning or learning? As we go forward, keep in mind the smarter the classification, the smarter the solution approach will be. So characteristics so one of the first characteristics we look at it is observability. So an AI system which operates in an environment, it can sense or access all aspects of that environment relevant to decision making. So we call it fully observable. So games like chess or checkers are the good examples. So nothing is hidden from the agent. But if the system can only access the partial information, such as robot navigating in a smoky building with blocked sensors, we call it partially observable. So this distinction is crucial because in a partially observable environment, the agent must make decisions under certainty. So this requires more complex reasoning and sometimes memory of past states. So this is one of the characteristics as observable and partially observable. So next we examine whether the environment behaves in a deterministic or a stochastic way. So in a deterministic environment, every action has a predictable outcome. If you take action A in state S, so you always end up in state S. There is no uncertainty. Again, chess is deterministic. So in contrast, stochastic environment includes randomness. For example, a self-driving car might decide to overtake, but the success of that action could depend on other vehicles, road conditions, or weather. So outcomes are probabilistic. So this changes how AI must act. So in stochastic environments, agents needs to account for risks, odds, and sometimes even prepare for the worst case scenario. So next distinction is between the episodic and sequential problems. So in episodic problems, the A's current action does not depend on previous actions. Each decision is made in isolation. So image classification is an example where every image is evaluated independently. But in sequential problems, each action influences the future state of the environment. Think of a robot assembling a product. One wrong move affects all future steps. So for sequential problems, planning becomes crucial and agents needs to consider long-term consequences of their actions. So next, let's see how stable the environment when while the agent thinks and acts. So a static environment is one where the world does not change unless the agent changes it. So in such cases, the AI has time to plan and think without worrying that things are changing behind the scenes. So in contrast, the dynamic environment is constantly evolving, possibly even while the agent is still deciding what to do. Think of a stock trading bot or an AI drone in a battlefield. So in such cases, decisions must be fast and the agent must sometimes act with incomplete planning. And then another critical property is whether the environment is discrete or continuous. So here in discrete problem, there are finite number of states or actions. For example, board games are discrete, limited moves and limited positions. But continuous environments involve variables that can change fluidly. A robot's arm positions or a car's steering angle can vary across a continuous range. Continuous problems require modeling using real numbers, calculus, and sometimes simulation. Algorithms must be adapted accordingly. And then next we consider how many decision makers exist in the environment. So in single agent problem, A is only actor, so it does not have to complete or cooperate. A navigation bot is a warehouse which might fall in this category. But in multi-agent systems, other entities like robots, humans, software agents also have goals and may be cooperative or adversarial. So this drastically increases complexity. A must now predict, coordinate, and compete with others. So games, autonomous vehicles, and distributed systems fall into this class. So here, what is the role of knowledge in solving a problem using AI? So knowledge is the foundation that enables reasoning. The more an agent knows about its world, the better it can predict outcomes, choose actions, and avoid failure. Right? So knowledge can be declarative, that is the facts, rules, procedural, so how the steps, or even heuristic. So it is based on experience based shortcuts. So AI agents use the knowledge to guide search, prune the bad choices, and focus on promising paths, making the problem solving efficient. Without knowledge, even the smartest algorithms becomes blind. Right? So, what exactly is problem solving? Problem solving is not just about trying things until something works. So, it's a structural process of understanding the goal, analyzing the constraints, navigating the problem space intelligently. So, it combines representation, reasoning, planning, and execution. So, AI systems are built to solve problems by mimicking how humans tackle challenges, but with the speed, precision, and consistency that machines offer. Okay. So one of the most important ideas in AI is the abstraction. Abstraction means simplifying a problem by focusing only on the relevant details and ignoring the rest. For example, when a GPS suggests directions, it abstracts away the things like building colors or weather. It focuses only on the roads, distances, and traffic. By using abstraction, AI systems reduce computational complexity. So this allows them to work efficiently even in large or complex environments. So choosing the right level of abstraction is an art. So too much detail which shows the systems down, but too little detail leads to bad decisions. So we have seen the different types of problems, AI agents which face, and the characteristics that influence how these problems are solved. So we explored observability, determinism, time, agents, continuity, and the role of knowledge. So this classification, which is not theoretical, it directly shapes how we design AI systems, choose algorithms, and evaluate success. Okay, thank you.